This is a tutorial on how to use the Igneous rock chart that's on page 6 in the reference table. So you should get out the reference table or science reference table now if you don't have it out yet, and it'll be very helpful to follow along and make notes in that. So it's on page 6 at the bottom of the reference of page 6 of the reference table. There are many things on here that will help you answer questions and identify igneous rocks, and I want to show you some of those things right now. So if you take a look, you'll notice the first thing that I want you to notice is that this chart is divided into two halves at the top here. If you take a line and you draw it right here between this chart, if you take this all the way across, and I'm not going to draw all the way across here, but you'll see that you have extrusive igneous rocks here and intrusive igneous rocks here. Again, igneous rocks are formed when molten rock cools, either slowly or quickly. If it's slowly, they cool inside the earth. They're called intrusive or plutonic igneous rocks. And that makes them have a certain size crystal. Extrusive rocks have smaller crystals because they cool very quickly. Exterior to the earth, they're called volcanic because most of these rocks are formed when volcanoes erupt. So if you look, the size of the crystals that grow, and you'll see this in lab, is determined by how fast these rocks cool. So all the rocks that are above this line right here, that goes all the way across except for this diabase, all these rocks were formed from volcanoes, and they have crystal size that are either fine or glassy, either very, very small crystals, less than 1 millimeter in size, or no crystals at all, glassy, looks like glass. And so this chart can be really helpful. So if we pick up a rock and it's glassy, then I know that it's going to be one of these four rocks. If it's got small crystals and you can actually take a ruler and measure it, you will see that if it's less than 1 millimeter, it's going to be one of these rocks. And if it has larger crystals, the texture is coarse or very coarse. And remember, again, this is not how they feel. It's the size of the crystals. That will help you determine that. So I do have one sample. I'm at home, so I don't have a lot of samples here. But if you look at this crystal, this rock, you'll see that the crystal size on this is fairly large. And all I have to do is take a ruler with centimeter measurements on it. And remember, there's 10 millimeters per 1 centimeter. And I take it and I find one of the crystals and I put this ruler on that. And you're not going to be able to see it because this rock is white, but it is about 5 millimeters, 5 of these little lines for one crystal, and I can see that crystal on this rock. And so that means that it puts it right here, 1 millimeter to 10 millimeters. It's going to be in this row somewhere. Okay, it's one of these. It's either granite, diorite, gabbro, diabase, peridot, or dunite. I've narrowed it down quite a bit just by identifying how big those crystals are. And it also tells me that it's an intrusive igneous rock as opposed to extrusive. That's one of the things that you can look at. The other thing is in terms of its texture, whether it has vesicular texture or not. If it has vesicular texture, if it has gas pockets, then it automatically has to be extrusive because it has to cool very quickly. And it's going to be in this row right here or in this row right here. One of those two rows. Those are the only ones that have vesicular texture. And the difference is just that these pumice and scoria are glassy but have gas bubbles. Vesicular rhyolite, andesite, vesicular andesite, and vesicular basalt are fine texture. They're not glassy. You can see the crystals, but they have gas pockets. So those are the two defining characteristics of the vesicular rocks. They can either be glassy or fine, and they're found in this row or in this row. The rest of these are non-vesicular. All the rest of these rocks are going to not have gas bubbles. So that's the texture and the crystal size. So if it asks you for crystal size or texture, that's what you look for. That's the first step, right? And the first step in identifying any of these rocks in the lab is to look at any of these, the texture, to see which row you're in. The next thing that I'm going to talk about on here is the characteristics, these characteristics down here. So when we look at these characteristics, whether they're light in color or dark in color, whether they're low in terms of its density or high in density, or its composition, whether it's felsic or mafic, those characteristics help us to determine what column the rock would be in. So if I take this example again, if I take this example, it's pretty obvious what the color is on this. And we could also look at the mineral composition, but we'll do that later. But you can see that this is what? Light in color. So light in color means that it's over on this side. And I already said that it was 1 to 10 millimeters. So it's 5 millimeters. So it's in this row, and it's over on this side. It's light in color. It's a granite. This is a type of granite. So it's as easy as that to help identify these. You look at the color, and you look at the size of the crystals, and that can give you really close to finding these. Some of the ones that are intermediate can be a little challenging, and we'll look at those in the lab. But these will have a mix, some dark minerals, some light minerals, and so it's sort of somewhere in between. And these have mostly dark colored minerals in them. And so these look black or dark green in color, and those are really easy to see as well in terms of the color. And once you know the color and the crystal size, you can identify these rocks pretty easily. That's in terms of what you need to identify for Regents Earth Science. We will talk more about the mineral composition in another video. It's a little bit more complicated and a little bit more than I want to get into right now. But just for now, knowing that on the left-hand side of this chart, obsidian, pumice, vesicular rhyolite, granite, and pegmatite, all of these rocks are lower in density, lighter in color, felsic. The higher density ones are on this side. So if you remember from page 10 in the reference table and our talk on in plate tectonics, that the continents are made out of granite and they have a density of 2.7 or low density, and the ocean is made out of basalt and it has a density of 3.0, that fits in this chart, right? Because basalt is darker in color, it has higher density, and granite has a lower density, and so when those two plates collide, the lower density granite rides up and over the higher density ocean crust, and so the ocean goes down underneath. So that's the what I want you to see when you're looking at this chart. There's a lot of information on here, but once you know how to read it, it's not too bad. So that's all we're going to do for now. We'll do mineral composition another time. Thanks.